Ever wondered how a simple ray of sunshine can power your entire city? It sounds like science fiction, but it's happening every day at massive solar power plants all over the world. Today, we're going to pull back the curtain and take a deep dive into the incredible journey of sunlight. From the moment it leaves the sun to the second it lights up your room, it's a fascinating process, so stick around. First things first, let's talk about the heart of any solar power plant, the solar panels. You've probably seen them on rooftops, but in a power plant, we're talking about vast fields of them, sometimes covering thousands of acres. These aren't just simple pieces of glass. Each panel is made up of many smaller units called photovoltaic cells, or PV cells for short. These cells are the real magic makers. They're typically made from silicon, a semiconductor material that's abundant in sand. So, how do these cells work? It all comes down to a phenomenon called the photovoltaic effect. When sunlight, which is made of tiny energy packets called photons, strikes the silicon cell, it knocks electrons loose from their atoms. Think of it like a game of cosmic billiards, where the photon is the cue ball hitting the electron. This flow of electrons is, by definition, an electric current. Specifically, the PV cell is designed with layers that create an electric field. This field acts like a one-way street, forcing all those freed electrons to flow in the same direction. This directed flow creates what we call direct current, or DC, electricity. It's the same type of power you get from batteries. Now, we have thousands, maybe even millions, of these solar panels, all generating DC electricity. But here's the catch. The power grid and most of our home appliances run on a different type of electricity called alternating current, or AC. So, the next crucial step is converting the DC electricity from the panels into usable AC electricity. This is where a device called an inverter comes in. In a large-scale solar plant, the DC power from sections of panels is collected and routed through heavy-duty cables to a central inverter station. These are not your small Boxanthawal inverters. We're talking about massive, industrial-grade units, often the size of a shipping container. Inside the inverter, sophisticated electronics rapidly switch the direction of the DC current back and forth, creating the alternating wave pattern of AC power. This process has to be incredibly precise to match the frequency and voltage of the existing power grid, which in most parts of the world is 50 or 60 Hertz. Once the DC has been successfully converted to AC, it's almost ready for its big journey. But there's one more step: stepping up the voltage. The electricity coming out of the inverters is at a relatively low voltage. To transmit power efficiently over long distances, you need to increase the voltage significantly. Why? Well, high voltage means low current for the same amount of power, and low current means less energy is lost as heat in the power lines. It's all about efficiency. This voltage boost happens at a transformer. The AC electricity from the inverters flows into a step-up transformer located at the plant's own substation. This device uses electromagnetic induction to increase the voltage from a few hundred volts to tens or even hundreds of thousands of volts. This high voltage electricity is now ready to join the superhighway of our electrical system, the national grid. From the plant's substation, the electricity is fed into high voltage transmission lines. These are the giant metal towers and thick cables you see stretching across the countryside. These lines form a complex network that connects power plants of all types: solar, wind, hydro, and fossil fuels, to substations in towns and cities. The grid is like a giant shared pool of electricity. Power plants add electricity to the pool and consumers take it out. Grid operators work 24/7 to perfectly balance the supply and demand, ensuring the system remains stable. So, the electricity from our solar plant is now zipping along these transmission lines, traveling at nearly the speed of light. When it reaches a substation near your neighborhood, the process happens in reverse. A step-down transformer reduces the super high voltage to a safer, lower level, suitable for local distribution. From their smaller power lines, carry it along your street until finally one last small transformer, perhaps on a utility pole or in a green box on the sidewalk, steps it down again to the voltage that enters your home. And just like that, the journey is complete. A photon that left the sun just over 8 minutes ago traveled 93 million miles to Earth, struck a solar panel, was converted from DC to AC, had its voltage stepped up, traveled across the country on the grid, and was stepped down again, is now powering your computer, charging your phone, or lighting the room you're in. But what happens when the sun isn't shining? This is a major challenge for solar power. At night or on very cloudy days, the panels don't produce electricity. To solve this, many modern solar plants are being built with energy storage systems. The most common solution is large-scale batteries. These are essentially giant versions of the lithium-ion batteries in your phone or laptop. During the day, when the plant is producing more electricity than the grid needs, the excess power is used to charge these batteries. Then, in the evening, as the sun goes down but people are still using a lot of electricity, the stored energy can be released back into the grid, ensuring a continuous supply. The scale of these operations is truly mind-boggling. A single large solar power plant can generate enough electricity to power hundreds of thousands of homes, preventing millions of tons of carbon emissions every year. From a simple photon to a complex, interconnected grid, solar power is a testament to human ingenuity and a critical part of our transition to a cleaner, more sustainable energy future. So, the next time you flip a switch, take a moment to think about the incredible journey that power might have taken. It could have started as a tiny ray of sunshine in a field hundreds of miles away. It's a beautiful system, and it's powering our world in a cleaner way, one sunbeam at a time. Thanks for watching, and if you enjoyed this journey into the world of solar energy, be sure to like this video and subscribe for more deep dives into the technology that shapes our world. See you next time.